Everybody knows, the mobile download of large amounts of data takes some time. However, what if 100 GB could be downloaded within a few seconds? This is exactly what the researchers at the Institute for Communications Technology at TU Braunschweig have been working on. The key for handling such large amount of data is the Terahead Communication. The frequency range up to a few gigahertz is busy with many applications and services for wireless communications and radio. Therefore, the terahertz frequency range is currently exploited. At 300 GHz and beyond, there have no services been provided yet. Thus, large bandwidth up to 50 GHz can be achieved, making a fast transmission of very large amounts of data possible.
The high frequencies can be characterized by high path loss, which we can observe already at short distances. This can be mitigated by high-gain antennas. In general, the wave propagation at these frequencies can be described as quasi-optical, which means that the propagation is similar like the propagation of light, and due to the small wavelengths, also smaller objects have already an influence on the propagation. Typical applications are intra-device communication, wireless links in data center, or backhaul front-haul links to connect base stations with high data rates to the backbone networks. And based on these applications, we can also see that the distance varies from a few millimeters up to several hundred meters.
In order to measure how well the communication at such frequencies works, the Institute for Communications Technology employs the so-called channel sounding.
The channel sounder consists of three components: the transmitter, the receiver and the base unit together with the control laptop. Here, up to 4 transmitters and 4 receivers can be connected to the base unit at the same time. To start the measurement, the transmitter and the receiver are placed in the room. The distance between them is limited to 20 meters due to the cable length. The base unit generates a clock to synchronize the transmitter and the receiver. The transmitter transmits a test sequence, and the arriving signal is recorded at the receiver. This data is then compared to the original data from the transmitter. In doing so, interference can be detected in the transmission. For example, if somebody walks through the propagation channel. In order to analyze spatial characteristics as well, we can mount the transmitter and the receiver on top of these rotating bases. The rotating bases rotate by 360 degrees and can scan all different combinations of angles of arrival and angles of departure. In that way, we can determine the position for which the transmission works best.
Channel measurements have already been conducted in trains and aeroplanes in order to provide passengers with entertainment programs wirelessly. In this way, cables and monitors can be saved and the aeroplane becomes lighter. In data processing centers, wireless connections enhance the flexibility and the capacity of the network. In vehicular communication, terahertz applications are also possible when it comes to data transmission between vehicles in a very short period of time. Here, the reflection behavior and the disturbance reaction of the vehicles were considered. Should you like to learn more about this, or should you be interested in performing measurements for your own project, please contact us.